Hello and most welcome to 1238 of the Heidegger series. And I would today talk about, continue the line that was taken up before. Roberto Unger, who've been cooperating with Lee Smolin for quite some stretch of time. And this is an article called The Science of the One Universe in Time. Subtitle: The Singular Existence of the Universe. This book, or article in this case, develops three connected ideas about the nature of the universe and our relation to it. The first idea is that there is only one universe at a time. The second idea is that time is real and inclusive. Nothing, including the laws of nature, stands outside time. The third idea is that mathematics has this one real time-drenched world as its subject matter. From a vantage point abstracting from both time and phenomenal particularity. On the view defined by these three ideas, the universe is all that exists. That there is only one universe at a time justifies using the terms universe and world interchangeably. If there were a plurality of universes, the world would be that plurality. The singular universe must, however, be distinguished from the observable universe. For our universe may be much larger than the part of it that we can observe. In this book, we use the words cosmology and cosmological to designate what pertains to the universe as a whole, not just its observable portion. Observational astronomy has continued in recent decades to make remarkable discoveries about the observable universe. Cosmology, however, risks losing its way. The arguments of this work are cosmological. They concern the whole of the universe and the way to think about it. Each of the three central ideas developed in this article has implications for how we interpret what science, especially in physics and cosmology, has already discovered about the world, and for how we view what science can and should do next. It has consequences as well for our view of the place of these scientific discoveries in our self-understanding. The first idea is the solitary existence of the universe. We have reason to believe in the existence of only one universe at a time. The universe in which we find ourselves. Nothing science has discovered up to now justifies the belief that our universe is only one of many. Although the universe may well have predecessors, the multiplication of universes in contemporary cosmology has not resulted from any empirical discoveries or inference from observation. It has been the outcome of an attempt to convert through this fabrication an explanatory failure into an explanatory success. The explanatory failure is the compatibility of a prevalent view of how nature works at the level of its elementary constituents, with many states of nature other than the one that we observe. Today, in the early 21st century, string theory, with its prodigious surfeit of alternative, consistent versions, almost all of them not realized in the observed universe. Provides the most striking example of such undetermination of phenomena by prevailing theories. The conversion of failure into success proceeds by the simple expedient of supposing that for each version or interpretation of the theory, in favor there is a corresponding universe in what it says is true. If these unobserved universes were held to be merely possible, the question would arise, why only one of the possible universes in fact exists. Therefore, the most radical form of the conversion of failure into success consists in claiming that these other universes are more than merely possible. They are actual, even though we have no evidence of their existence. The multiverse idea. The most widely accepted causal hypothesis today to explain the genesis of such a multiverse is eternal inflation. Postulating the creation of an infinite number of universes formed as bubbles from phase transitions on an eternally inflating medium. Within string theory, it is plausible to believe that such bubble universes are described by laws chosen by a stochastic process from the immense range of theories that are compatible with the string theoretical approach. The retrospective teleology of the strong anthropic principle, according to which the criterion of selection of the laws in our universe is that they make possible our human life and consciousness. Is the circle of prestidigation, Prestigitation. The sleight of hand represented by this combination of ideas amounts to an ominous turn in the history of science. It is a turn away from some of the methods, standards, and presuppositions that have guided and disciplined science until relatively recently. Although the opposing idea of the singular existence of the universe may appear self-evident to some scientists and to many non-scientists, it raises a problem of the first order. Individual being, wrote Aristotle, is ineffable. We can provide law-like explanations of recurrent phenomena in parts of the universe. But how can there be a law-like explanation of the universe as a whole if the universe is one of a kind? How can we offer such an account if we are not entitled to represent and to explain our world as one of many possible or even actual worlds? The theory of the universe would have to be the theory of an individual entity. For such a theory, the history of science offers no model. bit too warm here. Sorry for my silence here, but it is astonishing. And I think it's so important, so it needs to be repeated and repeated and repeated. I'll say it could be actually very helpful to use time as a lever. The inclusive reality of time. The second idea, defended and developed in this article, is that time is inclusively real. According to this thesis, nothing in this singular universe of ours remains outside time. The reality of time may seem an empty truism. In fact, it is a revolutionary proposition. It contradicts not only certain speculative doctrines that openly affirm the illusory character of time, but also ideas about causation and scientific explanation that may seem beyond reproach and doubt. When the idea of the reality of time is combined with the idea of the unique existence of the observed universe, it results in the view that this one world of ours and every piece of it have a history. Everything changes sooner or later. Recognition of the reality of time gives rise to a philosophical conundrum about causation. If time were not real, there could be no causal relations, for the reason that there would be no before the cause. And after the effect. Causes and consequences would be simultaneous. They would therefore be unreal, or mean something different from what we take them to mean. Nothing would distinguish causal connections which are time-bound from logical or mathematical relations of implications which stand outside time. What we in causal language call causes and effects would in fact be aspects of a relational grid in a timeless reality. However, everything is time-bound. That principle must apply as well to the laws, symmetries, and constants of nature. There are then no timeless regularities capable of underwriting our causal judgments. Changes. It is not just the phenomena that change. So do the regularities, the laws, symmetries, and supposed constants of nature. Our conventional picture of causation must be confused. For we seem to believe on the evidence on the way in which we use our causal language outside science as well as within it. That time is real, but not too real. It must be somewhat real, otherwise there would be no causal connections at all. It must not, however, be so real that our causal judgments are all adrift on a sea of changing laws. In this article we argue that the evidence of science, the deliverances of the science of today, viewed in the light of its recent history, does not entitle us to circumscribe the reality or the reach of time. Our causal judgments cannot indeed be anchored in immutable laws and symmetries. That need not mean that we stand condemned to explanatory impotence. Causal explanation, properly reinterpreted, and redirected. Can survive the overcoming of our equivocations about the reality of time. It can make peace with the view that time is real and that nothing remains beyond its reach. This intellectual program brings us face to face with a further riddle, a puzzle that comes into sight when we begin to take seriously the notion that the laws of nature as well as its other regularities, symmetries, and supposed constants are within time and therefore susceptible to change, rather than outside time and therefore changeless. We seem faced with an unacceptable choice between two troubling positions. One position is that higher order or meta laws govern the change of the laws. And other regularities of nature. In this event, however, the problem presented by time depends on the laws is simply pushed to the next level. Either such higher order laws are themselves within time and liable to change, or they are timeless and changeless. The other possibility is that no such higher order laws exist. Then our causal judgments would remain bereft of any apparent basis. The change of laws would seem an enigma for which no adequate explanation can exist. Change requires causal explanation, and causal explanations must in turn be warranted, or so it is traditionally believed by laws and symmetries of nature. We considered ways out of this dilemma. One of them plays an especially large role in our argument. As it has in the development of the life and earth sciences, and of social and historical study, although not of physics. According to this view, the laws, symmetries, and supposed constants change together with the phenomena. Causal connection, on this view, a primitive feature of nature. In our cool-down universe, they recur over a discriminate structure of natural phenomena, which is to say, they exhibit law-like form. In other extreme states of nature, however, those that occurred in the very early history of the universe may be or have been lawless. The idea that the laws of nature are susceptible to change and that the laws may develop coevally with the phenomena that we take them to govern may be puzzling. For the reasons that I have suggested, it renders unstable the laws of nature that we habitually take as warrants of causal explanation. However, it is neither nonsensical nor unprecedented. We are accustomed to invoke it in the life sciences as well as in social and historical study. It saves us from needing to appeal to speculative metaphysical conjectures, such as the notion of a multitude of unobservable worlds. The conjecture of mutability of the laws of nature seems to give rise to insuperable paradoxes. The impression of paradox, however, begins to dissolve once we turn on its head the conventional picture of relation between laws and causal connections. And recognize that the former may derive from the latter. Rather than the other way around. This idea may lead us to think in a new light of a broad range of familiar and intractable facts. Among these facts are the unexplained values of the universal constants of nature, especially of those constants that we do not and cannot use as conventional units of measurement, and that are, for this reason, conventionally called dimensionless. Their seemingly arbitrary values may be the result of earlier states of the universe and of the operation of laws and symmetries different from those that now hold. They may be vestigial forms of a suppressed and forgotten history, testimonials to a vanished world, the one real world earlier on. A simple way to grasp what is at stake for science in the idea of the inclusive reality of time and of its corollary, the conjecture of mutability of laws, symmetries, and supposed constants of nature, is to ask the question, where does these regularities come from? Because the laws and the symmetries of nature, as we know them, as we now understand them, fail to account uniquely for the initial conditions of the universe. We need to ask as well a second question. Where does these initial come from? And as I mentioned before, where does these initial conditions come from? It is a constructing of an ontology where one part constantly gets forgotten. The outsideness of the universe, the initial conditions, the unreality of time. All of these are tricks, so to speak, made by logocentrism, if you want, proposal, expanded into physics, and it's giving a fixation or a fixatedness, I would like to call it even. This fixatedness is the physical tension, the constant effect of friction in our lives, the idea of things not being calculated in the correct way, and that we lose our predictive power. We become distant to our own time. We are no longer in time. We are outside of it, and we lose our free will. Since we cannot regulate the flux even of our thoughts, they will start to occur classically, randomly, without focus and direction. So lack of concentration, I would say, is in itself a feature of the classical disrupted model. This is one of the strongest attacks on the outsideness of the universe and the unreality of time, because it's much more than an argumentative attack. This is an attack from within, and it speaks to your thinking and knowing capacities. It is not an ideological, religious, philosophical opposition or approach. No, it's the opening up of thinking as it is, seeing that there is a paradox which has turned into faulty thinking, and faulty thinking is venomous to our system.
Just put a short pause here.
But it's catching on here, without a doubt. Becoming progressively more interesting. I have to repeat, where does these initial conditions come from? The mysterious constants of nature help describe these conditions. They do not explain them. On the contrary, they require explanation. Which the established laws and symmetries fail to provide. Thus, even though we can count the constants together with the laws and symmetries as regularities, we cannot expect them to help explain the initial conditions of the universe. They form from the outset part of the problem rather than part of the solution. There are broadly three ways to approach these questions. A first approach is to say that the laws and symmetries comprise an immutable framework of natural events. They are what they are. If they fail to apply to the very earliest moments of the universe, or to explain its initial conditions, that must be only because our knowledge of these laws and symmetries remains incipient and incomplete. it is this first approach that, at least until recently, has been ascendant in the history of physics from Newton to Einstein. It represents part of the intellectual backdrop to the major discoveries of 20th century cosmology. An objection to this approach is that what we already know about a very early universe suggests that the laws and symmetries as we now formulate them could not have held in the extreme conditions that existed then and that may exist again later in the history of the universe. For example, in the interior of a black hole. How can we speak of laws and symmetries if in such extreme states there is no discriminate structure, no stable repertory of different kinds of things? Such as those described by the standard model of particle physics. Interacting in ways that laws and symmetries can capture. Another objection is that the initial conditions of the universe and therefore its subsequent evolution seem extremely unlikely if nature is indeed constituted as our laws and symmetries say that it is. Under this first approach, the initial conditions of the universe remain unexplained by the laws and symmetries. The laws and symmetries seem applicable only to a universe that has already organized itself in the ways that are characteristic of a cooled down universe. It is true that so long as it resists that temptation to succumb to a rationalist metaphysics. Science can never show that the universe had to be what it has become. Science must, in the end, recognize what I here call the facticity of the universe. That it just happens to be what it is, rather than something else. The problem with the first approach, however, is that it may prematurely and unnecessarily narrow the field open to causal inquiry. It may mistake nature for a subset of natural processes. It may codify as laws and symmetries how nature works in these familiar variations, those that prevail in the relatively cold and differentiated universe in which we find ourselves. It is one thing to respect the inability of science to show that the universe must be what it is. It's another thing to reduce science to a body of precise laws, symmetries, and constants that are unable to account either for themselves or for the initial conditions of the universe. A second approach to the question of where the laws and initial conditions of our universe come from is to take this universe as only one of a multitude. The chief objection of this explanatory ambitions shifts under this approach from the laws, symmetries and constants that happen to prevail in this universe of ours, to the laws and mathematical conceptions governing the multitude of universes. Of which ours would be only one. It will soon appear that there is hardly any difference in this view between laws and mathematical notions. The effective laws that have up until now been the chief object of science become, under this approach, simply a variant among many sets of higher order laws applying to the crowd of universes. The strangeness of the initial conditions of our universe can be discounted as a trait of a universe that happens to be an outlier in the crowd. The detachment of the higher order laws from the realities of the universe that we observe and the multifarious content lend them all the more to marriage with mathematics. The resulting ideas are not so much physical theories expressed in the language of mathematics as they are mathematical conceptions presented as physical theories. Under such a view, the distinction between laws and initial conditions disappear. The extreme limit of this idea is the notion that natural realities are nothing but mathematical structures. Because such structures are timeless, so must the states of nature that they compromise be timeless. To each mathematical structure there corresponds a universe instantiating that structure in all its particulars. Observational surprises reveal mathematical ignorance. The second approach, whether or not in its extreme form, is an invention of the late 20th and early 21st centuries. It has been almost entirely foreign to the history of physics. And cosmology until the last few decades. It arose by the circumstantial convergence of developments in particle physics, culminating in string theory, with the conjecture of a multiverse and the appeal to anthropic reasoning. It found inspiration and reinforcement in mathematics, given the central role that it assigned to mathematical ideas. An initial objection to this approach is at once methodological and moral. It invents imaginary entities, all the other unobserved and unobservable universes or states of affairs in particle physics. To save itself from having to confront in either particle physics or cosmology the failure of its theoretical conceptions to account for nature as we encounter it. In this way, it wastes the treasures of science, its enigmas. It's a sort of cannibalism to gain clearance, sharpness, exactness. In this process, something got sacrificed, and that is actually science itself, or I would say sharpen it and say knowledge. Knowledge was put on the sacrificial pod, and sacrificed it was, so that we now can live in that fixated reality where cause and effect cling into each other like cogs in a grand machinery. It makes for no freedom. It makes everything deterministic, and it makes you lose your own thoughts into a stream of cause and effect, often referred to as linear time, sometimes mistakenly pointing to it as objective clock time, which is not quite true. This is just marvelous. It's one of the most fantastic texts I've ever read. But to get to this point where it sounds this is so undecisive, I read something earlier, a critique of the book by Unger and Smolin, and that person felt that the attack or the problems with the multiverses were not that interesting. I would say they're incredibly interesting. But I do understand what he meant in this criticism. It feels like nothing at all. But it is the start of a whole tendency where we sacrifice something to gain something. And what we gain is hollow. It's a piece of not knowing, because this part, the initial conditions, are not known. So for each time we do that process in our heads, in our body, on a piece of paper, or in writing, thinking, discourse, you name it, we will lose half. And we are constantly losing knowledge. It's an inflation going on. And this inflation, when it catches on, I don't know that there is a stop to it, but I'm quite certain that I know this very tendency so eloquently and sharply described by Unger is the closing of the Western mind, is the Untergang des Abendlandes. Spengler will have it. This process started early on. It's been called the takeover by the left hemisphere, which it is, but I don't think it explains enough. This explains enough. It tells us if this overarching tendency is in place, there is no escape from an overtake by the Western Hemisphere. It is almost that it has to take over. And it might be that it didn't even want to do that. No, I wonder, I don't think it wanted to do that. It was forced by this development in knowledge. There, maybe the Greeks got traumatized and they shut a part of their experience off, as traumatized people do. If you get hit in your youth, you try to avoid that. But avoiding that will make you lose a part of your life every minute and second. This is similar on a more, it feels like reality. It is part of the background. It has been part of the background for millennia. It's natural. But now it is getting its effect more than ever. Excellent. Bravo, Roberto Unger. I say thank you very much and have a very pleasant afternoon. Bye bye for now.